Hello, my name is Dan Lo. In this video, I'm going to talk about an interesting interview question. So here's the question. So given a program in Java, Python, C, or any other program languages, okay? And your job is to write another program to determine if the program, that means this program, okay, print out something. So, well, there are some tries, to solve this problem. So basically, we can look at it as this diagram. Okay. So this is the program you're going to develop. Okay. And we call this program you're going to develop PS. Okay. And then there's input. So input is this program, a program. Okay. And the output, okay, it's gonna be yes or no. Yes, if this program print out something, and then no if this program does not print out something. Okay. So if you were asked during the interview, okay, and well, you may start thinking about how to develop PS. So start with the some compiler techniques, parsing. Okay. So you know this is a program. Okay. We also in the program in source code like Java, like C or Python, or C. Okay. So you start talking about how you're going to develop PS. Okay. And so the PS basically is you try to scan through the source code of the program P and check if there are any output statements. So for example, in C is a printf. Okay, something. Okay, in Java like a system.print. So it scans through the source code. If you try to find if there are any printf statements or anything equivalent to the printf. Okay. And now, if you cannot find any of the printf statements in the program P, then output is actually no, because the source code of P does not have any printf statements. Therefore, you cannot output anything. Okay. However, if you do find some printf in the source code P, okay, now whether the program will print out something, it depends on the logic, right, of the program P. So it's you're not sure. Okay. So then you go spend probably 15 minutes, 20 minutes, maybe 30 minutes. You still cannot develop its PS to solve this problem. Okay, and in fact, there's no such program exists to solve this problem. And notice that it doesn't mean you cannot write a program to solve this particular problem. You can still write a program, okay? But this program, the PS, okay? You can write a program, but program does not solve it, okay? And this type of program is what we call undecidable program, okay? And so if you know this program is undecidable, then you wouldn't go through this route to develop the PS to solve it, because you can, okay? You can develop any program, okay, any PS program, but it doesn't solve this problem, okay? So you need to go through the other route to show this problem is undecidable, okay? So so here's how you prove that this problem PS is undecidable, okay? And to do that, you first had to know the problem H, okay? And we call the hello world. Hello world, there's space, okay? Hello world problem. Hello problem, it's not hello program, okay? It's different. Hello program is a simple program that prints a line, hello world. But hello world problem is well-known undecidable, okay? So this hello problem basically is like this. You given a program, okay, and it is undecidable to determine if the program prints hello world, okay, it's undecidable, okay? And I will now prove this here, but you just use this as a fact, okay? So PH is undecidable, hello world problem is undecidable. So given a program, to determine if the program prints hello world is undecidable, okay? Now we also have to use another tool called reduction. So reduction is like to solve a problem, I can use another solver, to solve it, okay? So we say P1 is reduced to P2, okay? If I can if I can find an instance W, okay, in the problem P1, okay, and then I develop a algorithm, or function to convert, okay, or translate, okay, convert W to an instance X or P2, okay, such that if W has a solution, if only if X has a solution. A solution of P2. Here I don't want to use W is impure, so they say W is an instance of P1. Okay. W, or let's say W is an instance of P1. Okay. And I'm going to use this notation W in P1. Simply saying W has a solution. Yes. Okay. If W, if the problem P1 is like a hello problem, saying if given a program, the program does print out hello world. So that's yes. If that's the case, then W is in P1. Okay. W in P1 means W has a yes solution. Okay. So if and only if X in P2. Okay. If that's the case, then we say P1 is reducible to P2. Okay. If P1 is reducible to P2, okay, that means given an instance W, okay, if W in P1, if only X is in P2, and X is coming from the W, okay, so this conversion is computable. It's like a program. You do the conversion. Okay. So is that the case? Then P1 is reducible to P2. Okay. Then if P2 is undecidable, okay, then P2 is also undecidable. If P2 is decidable, okay, if we know P2 is decidable, then P1 is also decidable. Okay. And we're going to use this reduction. Okay. And now we know the pH is undecidable. Okay. So if we can prove that the pH is reducible to PS. Okay. PS is the problem we discussed earlier, print out something. Okay. Then PS is undecidable because pH, the hello world problem, is undecidable. Okay. Now, so to show the pH is reducible to PS, okay. So here's the idea. So we want to create a case that convert an instance, and this instance is any instance of pH hello world. So a program, like a program. Okay, W. Okay, so so here's how we convert W to X. So W is in pH. Okay, so the conversion start out this. Okay, so we first we search search any statement, print. Let's assume that W is a C program, and any program is the same. Okay, an output statement. We search any printf statement in W. Okay. And then we do this. Okay. So if the printf print hello world, okay, if it prints, it try to, okay, hello world. You print hello world, keep it, okay. Now if it does not, okay, so we search any input or print any printf statement, okay, in W, okay. If it prints hello world, we keep it. If it does not, it prints something else. If it does not print hello world, okay, it prints something else, okay. Okay. When to remove it or delete it, okay. Okay. Now, after this modification, okay, we let the X be the program. Modify the program. So this modify program is from W. And this process, okay, search, okay, you can write a program to search, okay, and you can search any printf statements, okay, to find if it print hello world, okay. If it is, keep it. If it does not, okay, and then we remove it. Okay. So now we got a W, got a X. Now I want to claim that W, okay, W prints hello world. If W print hello world, okay, then we know the X is an instance of the PS. So X must print out something because you already print hello world, okay? Something. And that something is your hello world. Okay. So from, let's take a look at from the left to right. If W prints hello world, and notice that in the modification process 1, step 1, we keep that hello world, okay? Keep it. So that statement is in X. So if W does print hello world, then X also print hello world is something, okay? So from the modification process steps, okay, we know from left to right, so this is for sure. And from the left to right, okay, if X prints something, okay, notice that the X is a program modified from W in a way that we remove all the printf statements that does not print hello world. Okay. So if X print out something, then that something must be hello world, and that hello world must be coming from one of the statements in X, in W, sorry, actually print hello world. Okay. So we claim W prints hello world if and only if X prints something. Okay. And that is the reduction condition. So the result is we show that pH, this is a hello world problem, is reducible to PS. Okay. So if pH is reducible to PS, and we know the pH hello world is undecidable, then PS must be undecidable too. Okay. So that is the complete proof that the PS is undecidable. Now, another similar problem. Okay. Now let's consider another problem called PE. Okay. So PE is the problem that given a program, okay, determine if the program does not print out anything. Okay. So this problem we call the PE. And if you take a look at the definition of PS, okay, so PE is actually the complement of PS. The complement, because PS is given a program, determine if the program print out something, okay. But now the PE is given a program, determine if the program does not print out anything. So it's actually a complement of PS. Okay. So the questions now is PE undecidable? Okay. If it's so, well, it looks like it cannot be undecidable because PS is undecidable, right? So the complement, well, look like undecidable. But now the problem is if we guess it's undecidable. So the next step is, can we reduce hello world, okay, to the PE? The answer is no, we can't. But how do you know we can't? Okay, we can give it a try. Okay, so based on the reduction, okay, you will try to reduce pH to PE. Okay, now we find the instance W, okay, of pH, and then we try to convert W to an instance of X in PE, and such that W is in pH if and only if X is in PE. Okay. And so the problem is turn to how do we convert W to X? Okay. So we can follow a very similar procedure. Okay. So step one, we search the printf statements in W. Okay. Now, if W, if printf print hello world, okay. If printf print hello, if the printf, if we found printf, it prints hello world. Okay. If it prints hello world, and then we want this modifier program to be in PE. PE means print nothing. Okay. If we print hello world, then we want to print nothing, so we cannot keep it. We need to remove it. Okay. And if it prints something else, okay, it prints something else because it prints something else that we cannot have it, because we want a program to be not print anything, so we also remove it. Okay, so it basically you remove, so the net effect is you remove all the printf statement. And then after that, we let that program to be X, the modified program to be X. And notice that X contain no printf statement at all. That means this F does not print anything else, for sure, because when you remove all the printf statements. It seems okay, but it's actually not. Okay, so now, if we are trying to show W is in PH, if and only if X is in PE, we actually cannot do it. Why? Okay, so from here, if W is in PH, that means W prints hello world. Okay. If W print hello world, since X we remove all, so X is always print nothing. If that, so X print nothing. That's okay. Always, X always print nothing. Okay. So it seems okay. But the problem is that from the right to left, okay, if X is in P, that means X print nothing. So if X print nothing, okay, and then the W actually, if X print nothing, okay, if X print nothing, we don't know whether W print hello world or not. Okay, W, because we remove all the printf statement, so W prints hello world. No, we don't know. We cannot be sure. We cannot. So this part we cannot set up this reducible condition. So we cannot reduce pH to PE. We can. This one we can. Well, just because you cannot develop from W to X, it doesn't mean you can't. They may have some other algorithms or another idea, to convert W to X. Okay. So this try fails. So this try fails doesn't mean this is not reducible to PE. Doesn't mean. Okay. But you can keep trying. You can keep trying. And as a matter of fact, pH is not reducible to PE. Okay. So we know the pH is reducible to PS. Okay. PS. Right. And pH is undecidable, and therefore pH is undecidable. PS is also undecidable. All right. And we know PS is the program the given program, okay, and determine if we print something, okay. We can write a program. If print something, so we can write a program, okay, to check if PS print something, okay. Print something out by simulate P, okay. Simulate P. As long as P prints something, and then our answer is yes. So this P can be computed, okay, by a program PS to check. Okay, cannot be. But if P get into the loop, then we don't know. But if P does print out something, then eventually we will find the answer. So we call this type of problem PS is computable, or another way called the recursive enumerable. Recursive enumerable. That means you can write a program to compute it, but you cannot solve it. Okay. surgical recursivity. I call it RE. Okay, RE. So PS is RE. PH is also RE. Okay. So the problem of PE, well, we try to set up the reduction relation, but we can't, right? So it turned out that the PE is not only undecidable, but it's also non-I. You can't even write a program, to compute it. All right. So to show that, we need another theorem. Okay. So if P is RE, recursive enumerable, okay, and P bar, the negation, is also RE, okay, then P is recursive. Here's recursive, another name is called decidable. Decidable means if P is recursive or decidable, okay, then we can write a program to determine, given a program, okay, then we can fully determine if W is in P or not. That's called decidable or recursive. Okay. Okay. Now we know P. Don't forget, the PE is the complement of PS. A program print out something. Okay. And we know PS is RE and undecidable. Okay. So assume PE, the complement of PS, is RE. Assume. Okay. Then both PS and PS bar are RE. If both PS and PS bar are RE, then we know the PE and the PS, okay, PS or PS bar must be decidable or recursive. But we know PS is not. PS, we just say, is undecidable. Okay, but PS is not. And therefore, the PE cannot be. The assumption is wrong. PE cannot be RE, so PE is non-RE. Okay. So problem is non-RE, that means it's undecidable. Okay, so we can use this diagram, okay, to show the relation. So this is recursive or decidable. Okay, and that's outside. This is RE. And decidable must be RE. Okay. And outside this is non-RE. Okay. So a problem is undecidable. It could be in here. It could be RE, or it could be non-RE. And here we have the problem H Hello world is RE, undesirable. Problem as print out something is RE, undesirable. Okay, and the PE is actually outside the circle. It's non-RE. Okay. So the difference between PE, a program print out nothing, versus the program print out something, okay, is that the program print out something, we can write a program to test. So it's in RE. RE means computable, in other words. And the non-RE means you can't even write a program to do this. PE, you can't. They both undesirable, but one is computable. PS is computable. PE is not. Okay. So, and that's all I have. And if you have questions, you can leave a comment below. Thanks. Have a good day. Bye.